In this video, I will be explaining two things. First, what is an effective rate of interest? And second, I will be explaining how to compute an effective rate of interest. To understand what is an effective rate of interest, I will be using an example. Assume that $100 was invested at 8% compounded monthly. And the question is, what would be the maturity value of the investment at the end of 1 year? We know the formula to compute this maturity value of the investment. So I'm going to use the symbol S for the future value or maturity value, and P, the principal or present value. So we know that the future value will be equal to the principal to the present value multiplied by 1 plus I to the power n. And in this problem, they are telling me what is the principal, what is the amount that is invested, that is $100. We also know that the rate or nominal rate of interest is 8%. And this is compounded monthly. So this interest is compounded 12 times per year. I'm going to use the symbol M for the number of compound periods in a year. So in this case, because it's compounded monthly, it will be 12. The number of compounded periods in total will be the number of years multiplied by M, how many times the money compound per year. So because it's only 1 year, it will be 1 times 12. So n will be the same number of m in this case, where n will be 12. So we have everything, and this I is actually the nominal rate of interest divided by 12. In this case, divided by the number of compound periods in a year. So then the formula is actually S equal P, the present value, 1 plus R over M, the nominal rate of interest, divided by the number of times the money compound in a year. In this case will be 12 to the power n, that in this case will be also 12 because it will be only 1 year. So we make a substitution of everything and we can compute the future value. So the future value will be 100 multiplied by 1 plus 0.08, that is the 8% that we have here, divided by 12 to the power 12. To the power 12 because it's only 1 year, it's the first year, it's only 1 year. Okay, so we have then, we use our calculator and we compute this is 108.30. So what does it mean? That in 1 year, $100 produce $8.30. So we notice that this investment produces $8.30 per $100. So for each $100, $8.30. What does it mean? That this produces effectively 8.30% per year. So this is the effective rate. It means that the effective rate of interest in this case will be 8.30. Why? Because it's producing 8.30 per $100. So this is actually the effective rate. The rate is 8%, but this interest is actually producing 8.30%. So 8.30 per each $100. So this is the effective rate. Another thing will be how to compute the effective rate if we know the rate. To understand how to compute the effective rate of interest, let's use an example. Assume that we have this question: what is the effective interest rate on an investment if the interest rate on the investment is 11.3111% compounded quarterly? So we have the nominal rate of interest and is compounded quarterly, and we want to compute the effective rate of interest. So what I'm going to do is first obtain a formula, and after we have a formula, we solve this problem. But let's see. What we have so far is that the future value equals the present value multiplied by 1 plus I to the power n. And I will be thinking in just investing $1 per 1 year. So my principal will be $1, and we have here the nominal rate of interest that is 11.3111%. So this is the nominal rate of interest, and it's compounded quarterly. So we know that compounds 4 times per year. So we know M, the number of compounded periods. We also know, and we are going to be thinking also, that this investment is for 1 year, just to make the things easier for us. We're going to be thinking of a principal equaling for $1, and the time is going to be 1 year. So if the time is 1 year, then the total number of compound periods will be 1 year multiplied by 4 in this case. So it will be 4. So in the way I'm solving the problem, n and m will be the same number, because we are multiplying by 1. And what we want to compute is the effective rate of interest. Let's call it f. This effective rate of interest will be a rate of interest that is compounded annually that produces the same future value given the principal. We know that the future value will be 1 multiplied by 1 plus r over m to the power m. In 1 year, that was going to produce $1 in 1 year. Using this rate of interest will be 1 multiplied by 1 plus r over m to the power m. In this example, m equals 4 and r equals 0.113111. So this is actually 1 plus r over m to the power m. So the future value formula shows reduced to this factor, 1 plus r over m to the power m. If we invest $1 in 1 year. And now if we invest $1 in 1 year, but now using the effective rate of interest, so the formula will be then s equal 1 multiplied by 1 plus f to the power 1. Because it will be one compounded period, which only one is compounded annually, the effective rate. And we are investing $1. So this is the formula of future value if we invest $1 using the effective rate of interest. So actually we can write 1 plus the effective rate of interest. This is the amount that we're going to have at the end of 1 year if we invest $1 using the effective rate of interest. But the effective rate of interest is a rate that is equivalent to this. So the future value of both will be the same. So we can say that these two amounts are the same. So these two final amounts are the same. So we can say that 1 plus f is the same of 1 plus r over m to the power m. And we can solve for f. If we solve for it, we just type this one at the other side negative. So we have that f equal this, and we have a formula to compute the effective rate of interest. Usually in the textbook appears instead of r over m, you can write I, the periodic rate of interest. So you can see that the formula sometimes is written in this way. F equal 1 plus I to the power m minus 1. This I is the periodic rate of interest, the interest given. And this m is the number of compound periods for the given nominal of interest. So we can use this formula to solve any problem. So let's solve this problem using this formula. So we have that the formula is f equal 1 plus I to the power m minus 1. So we know then that we can type it in this way because this periodic rate of interest is actually r over m. And you notice that the formula of effective rate doesn't need of the principal and it doesn't need of n. So this information is not necessary actually for any problem of effective rate of interest. So if you have the nominal rate of interest and how many times the nominal rate of interest compound per year, you can compute the effective rate of interest. So the effective rate of interest in this case will be 1 plus 0.113111 divided by 4 to the power 4 minus 1. So that will be just making the substitution of the effective rate of interest and using the calculator. So the answer will be 0.11799,873. You should write this in percent, so multiply by 100 and the answer will be 11.80. I rounded to 2 decimal places, but you noted that even if I round it to 4 decimal places, the answer is the same in this case, 11.80%. So let's solve another problem. What effective rate of interest is equivalent to 9% compounded semi-annually? So in this case, we know that the nominal rate of interest is 9%, that is compounded semi-annually, so m equal 2. So there are 2 compounded periods, and we need to compute the effective rate of interest. Then we use the formula of effective rate of interest, and we know that this I is actually the nominal rate of interest divided by m. Yeah? So we can type it in this way. And because we can type it in this way, we can also we can make a substitution immediately. This R will be 0.09, this m is 2, and then after the substitution, that is what we have. Then use the calculator, and you will notice that this is the answer. 0.092025. Type this in percent, so multiply by 100, the answer will be 9.2025%. We have another problem. Let's see. What effective rate of interest is equivalent to 9% compounded monthly? What happens if we have the same problem, but now it's compounded monthly? So we know that R equals 9%, that M equals 12 because it's compounded monthly, so it compounds 12 times per year, and we need to compute the effective rate. I use the formula, so actually you can type it in this way, and then make a substitution, 0.09 divided by 12, and this to the power 12. Notice that the formula of the effective rate of interest have the same number as the denominator and the exponent. Then use your calculator, and the answer is this. I will be multiplying by 100 and rounded to 4 decimals. So the answer will be 9.3807%. And this is the effective rate of interest if the money compound 9% compounded monthly. What does it mean? That actually with this interest you are getting 9.38 cents per each $100 that you are invested. So you are getting 9.3807% per year. You are earning $9.3807 per $100 of investment. And with this example, I finish my explanation of what is an effective rate and how to compute this. Thank you.